we're going to talk about piecewise functions, how to evaluate them, how to graph them, and how to write an equation given a piecewise graph. So a piecewise function is going to be a function that's defined by a different equation over different parts of the domain. And to evaluate these functions, you have to take an extra step. You have to decide which part of the function you need to plug x into based off of the value of x. Let's take a look at that. So if we're looking here, we have our equation up at the top. Notice that it has three different pieces. Okay, three different pieces. Now we just have to decide where x falls. So the first one, we've got f of -1. So we're going to come over to our intervals, and we have x is less than or equal to 0. X is greater than 0, but less than or equal to 2. And x is greater than 2. So x being -1 falls in that first piece. So I'm going to plug it into x plus 6. So I'm going to have -1 plus 6. So I'm going to get 5 there for my final answer. When I do the same thing for 0, it says less than or equal to 0. So I'm plugging it into that first one. So I've got 0 plus 6. So when we add 0 plus 6, we're just going to get 6 for our final answer. Got 1, so we plug 1 in, and notice that 1 falls between 0 and 2. So our final answer is just 6 again. We're going to take 2, plug it in. It still says x is less than or equal to 2, so that answer is also just 6. Remember, if the value is just a number, it's a horizontal line at that number. So we've got 3, which falls into x greater than 3. So we're going to do 3 squared minus 1. So that's 9 minus 1, or 8. And then for 4, again, still greater than 2, so 4 squared minus 1 is a 16 minus 1, or 15 as our final answer. So that's evaluating based off of the function. Now we're going to talk about evaluating based off of the graph. So we're looking at the graph, and just like we did with the equation, we're just going to take that x value it gives us, so f of 2, so is our x value. We're going to come to 2, and we're going to say, okay, where is there a value? Oh, right there, at 4. So our answer would be 4. Do the same thing for 3. Now 3, we have a hole at 6 and a point at 2. The value is 2. Holes don't hold a value because they're not actually on the graph. And then f of -1, we look at -1, all we have there is a hole, so it's going to not exist. It does not exist. Okay? So we've evaluated based off the graph, we've evaluated based off the equation. Now we're going to talk about writing a piecewise function. So if we look at the graph here, we have to write an equation based off the graph. I always start with my intervals. So the first one I'm seeing is from -4 to 2. So I'm going to have x in the middle, and then I'm going to know that it is greater than or equal to 4. Okay, so I know that because the hole is included there. It's a closed circle. And then at 2, it's just going to be less, well, that should be a -4, less than 2. Then I'm going to look at my second interval. It starts at 2 and then goes to infinity. So x is greater than or equal to 2, because 2 is included for that piece. Now I'm going to write the equations for each piece. So the first piece from -4 to 2 is a straight line at 3, so all I have to put is a 3. Okay? And then the second equation there actually has an equation. First you look at the slope. It has gone up 1, 2, and over 1, right? Let me double check. Up 1, 2, over 1. So I have a slope of 2x. And I just need to find my y-intercept. So I'm going to keep applying that up 1 over 1 until I get to some sort of 0 on my y-axis, even though it's not included on this graph. So down 2 over 1, down 2 over 1. So I'm going to end up at -6. So I'm going to subtract 6. And now I have written my full equation. Out in front, we normally will put f of x and then equals and now we have our equation. Sometimes there will be more than 2 parts. You could possibly have 3. Okay? So you really need to know your parent functions to write these. Okay, graphing the equation. Graphing the equation, I always start with my fences, which are going to be those values that are part of our intervals. Now, I talk about this as fences and yards because I think it makes it a lot easier for us to understand. So we've got our first fence that's going to be at x equals 1. Okay, we've got another one at 4. So those are where our 2 fences are going to be. We've got equations that are going to lie within the fences or on the outside of the fence. So we're going to put a fence at 1. We're going to put a fence at 4. The first top equation is to the left of the fence at 1. Okay? Now I'm going to rewrite it so that's y equals mx plus b form. Okay, so that's negative x plus 1. Which means on the y-axis I've got a point at 1, and then I've got a negative slope. So it's going to go down 1 over 1. So when it reaches the fence, because this is not a greater than or equal to sign, okay, or less than or equal to sign, I'm not including it. So that means it's a hole. So I'm going to put a hole on my fence, okay, and then I'm just going to draw my graph wherever in that direction. Okay, going up 1 to the left 1. The next piece is a straight line at 2. It's going to be including 1, okay, and then not including 4. So I'm going to go up 2 and put a point and then a hole on 4, and then I'm going to connect my pieces there. Okay? And then the last one, it's a parabola, right? I'm noticing that it's square, or quadratic. Okay? And I've just shifted it to the right 4 because it says -4 there, right? So it's actually a shift to the right 4. So I'm going to go to the right 4. And I'm going to have a point because it's greater than or equal to. Okay, so the typical quadratic graph has a point at 0, 0. Then if I go over to 1, right, it goes up 1. So I'm going to go over 1 for my green dot and up 1 and put a point. Then I've got my normal quadratic. If I go over 2, I go up 4. So if I go over 2, I'm going to go up 4 from my dot. And then if I go over 3 for my dot, I'm going to go up 9. And there we would have a quadratic shifted to the right 4. Again, this is graphing piecewise functions. If you have further questions, please see me in class. We'll be doing some practice.